Alright, should be a video. Probably, maybe. Probably needs me in it, so I'll put me in it. Hi. Alright, anyway, usual routines and such. And whatever. So, pop out shot. Alright. Put it somewhere I can see it. And I will do the business first, which means we need to find some videos here. Oh, you should be seeing that. Yes, you are. Alright, so the Iron Gosling has made a couple of videos. Haven't watched this one yet. Closer look at springs. So maybe we'll play that one. We'll paraphrase some of these others. I guess we'll play this one just because it's so obviously not too bright.
To show the difference in the acceleration of two different arms.
Okay, so he's made two levers, right? And one of them is only half as long as the other. Alright, so, really shouldn't have to go into how there's a whole hunk of mass missing from one of the levers, a gigantic piece of the mass. And then he talks about how one moves easier than the other. Yeah, because it's got less mass. So there's no even point in him having the two mass here and the one mass out here when he's missing half the lever. So when you do the test of comparing the two, you still have to have the same amount of wood, whatever the levers are made out of. I assume it's wood, attached to the lever. So obviously that's not a fair comparison. Alright, so this all relates to, I might as well play his other video. So I mean, really, just a pointless video. I mean, just let's see if there's a place here where he's actually oscillating them. He's gone to all this trouble, put new springs on it, all this crap. He won't do the basic experiment, which is, can you convert momentums? Can you take a 5-ton train going 10 miles an hour and convert it into a 10-ton train going 5 miles an hour into a 5-ton train going 10 miles an hour? Can you do those conversions? And yes, that's my argument, that that's what levers do. And so instead of dealing with that basic fundamental argument, what's conserved, kinetic energy or momentum with levers and springs, they're doing this crap. The other problem is I don't think he has weighed whatever he is using as a bearing on these things with weight. So the bearing itself is an object with mass, and you've placed the same object with the same mass in both locations, which doesn't work. You can't do that either. So I mean the theory is so misunderstood and abused here that what's the point?
1, 2, 3, go.
So I mean, obviously two very different arrangements of the lever. Doesn't really, again, doesn't make any sense to sit there and worry about what weights you have on here when the levers themselves aren't the same mass. The levers have to weigh the same for you to make this comparison. You really shouldn't have to say that. But anyway, fine, whatever. Alright. Now this one, he's talking about the rotational speed. I didn't play the whole video, but I don't think I need to, because I don't think he's saying anything, but I'll play it I'll play it now.
In Draft Science's live stream on April the 2nd, it was, he's talking about why Marble's experiment was wrong, or why...
Yeah, well, I was mostly thinking about your experiment, okay, where you had the two mass on one of your sticks and the one mass on the other stick, and the two mass stick was moving slower, okay, in spite of what you were saying, because the one mass clearly bounced much higher, at a much larger amplitude. And so I was explaining with that in mind, which was probably a mistake. But clearly in your case, I think it can be understood that the friction is the thing that's different about the two experiments. So I don't think there was anything wrong with the explanation I gave, that when something's in the vertical position, when the lever's in the vertical position, The weight from both sides is in the same direction on the bearing, both down. The hanging weight and the above weight are both pushing straight down on the bearing. Where when it's in some other position, okay, the bearing is pushing both up and down, and there's I wouldn't call it a balance, but the bearing is changed in terms of the pressure. And that's the whole point of dangling the weights, is it changes the pressure, because it pretty much changes the weight. The weight changes when you turn it because the angle at which the object is sitting changes. So if it's on top, this angle, this side gets heavier and this side gets lighter, because the weight is moving closer or further away from the fulcrum. And that's why it balances, is because the weights are changing, essentially. So the masses stay the same, but the weight changes because it gets closer and further away to the fulcrum. That's why it oscillates. All right. I really don't think he says anything here. Well, it's only a minute.
He's explaining why there is a difference in the rotational speed when you've got masses.
So I was, again, you didn't rotate them, you only swung them in this 90-degree arc, and I was explaining why you were getting a difference in that 90-degree arc. But whatever, fine.
Two mass here and a two mass here, and then you've got a one mass out here. There's a difference in the speed, and he's explaining why that is.
Yeah. The whole thing started because I'm saying something very explicit, and you keep doing experiments that have nothing to do with that explicit statement. So I'm saying when you have it balanced, okay, you hang a weight or you have a weight on top of the lever, it really doesn't matter, even are in alignment, and you press on one side of the lever, the weights will be the same. You will not tell the difference because the lever will move the same for the one mass further out as it moves for the two mass closer in. So if you put everything at the right positions and you get the weights just right, that's in fact what will happen, is you will not be able to tell the difference in the weights. You keep saying you're proving that wrong with all this spinning crap. I'm saying foul, wrong. That's not how you prove me wrong.
And he says, if I get this right, if you have a two mass here and a two mass here, it's heavier than when you've got the two mass here and a one mass here. Oh,
it's physically a fact that it is in fact a different mass. So if you weighed the whole lever, it would weigh a different mass because the total mass of the lever would be in fact different. So it's hardly a bold assertion to point out that yes, the whole experiment weighs a different amount. Oh, shit. And clearly when you're rotating it, you're breaking the idea of a balance because you really are balancing everything out. Everything that happens on one side, you're doing some kind of opposite on the other side, and then you're reversing the circumstance. But you don't want to pay any attention to these reasoned arguments. You just want to do this gimmicky bullshit.
overall, the first case is heavier. And he says that explains why, because it's heavier.
So he's not even putting it in the vertical position. I said in the unique circumstance of the vertical position, there is in fact more mass on the bearing when it's not rotating. When at the very moment it's not rotating and it's in the vertical position. It's just a fact that there's more weight on the bearing. That's what I said. And you can't even be honest enough to show it in the position I made the argument from. I mean, I explicitly drew it. You just don't care about those facts.
Slower. He says the two mass and the two mass will rotate slower than the two mass and the one mass.
In the case of your half turn, I'm saying that's the reason why it moved slower, is because there was more friction on the bearing. So again, I'll point out that my response was more to you than mindless marbles, but I did reference his video, and I probably shouldn't have.
Because the two mass and the two mass is heavier, causing more friction, and it rotates slower. Well, of course, what he missed is the two mass and the one mass rotates slower than the 2 mass and the 2 mass.
And then in your video, somehow the 1 mass was rotating faster. Just a fact. I mean, you said the opposite, but it's a fact that it had to be rotating faster because it had more energy in it when it hit the spring, and it bounced back further. So it wouldn't have bounced back further if it didn't have more energy.
It goes slower. The lighter thing goes slower. So it would have less friction, favoring.
So he keeps saying it. This is how levers work, that something, whatever, some inertia thing does some sort of thing. All right, some fake, phony word somehow slows down the process. And again, it has to slow it down for their theory to be correct, in the sense that they're saying levers conserve kinetic energy, and they, abolish the conservation of momentum. So they don't conserve momentum; they conserve kinetic energy, which means it has to go substantially slower, 0.6 slower.
The favouring the other one.
Well, 1/3 slower, whatever you have to calculate the 0.6 into a doubling of the speed. It's not a doubling of the speed, it's only a 0.4 increase in the speed, even though the weight's half the mass, blah, 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 blah.
No, it's got a 2 mass and a 1 mass is lighter, so there should be less friction.
Okay, so there's no point. He won't even acknowledge that I made an argument very specific to when the lever's in the vertical position. Then, okay, you can argue that there's absolutely no upward forces anywhere. Nothing's moving in the upward direction. Everything would be moving by gravity in the downward direction. All the force would be in the same direction. So it doesn't even acknowledge the real argument.
So it would go faster, you would think. It should go faster. But it doesn't. It goes...
Blah, 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 blah. So, okay. So let's deal with the mindless marbles argument. And that would be, maybe it's here. Yeah, okay. Here's the rotating crap on the pendulum thingy. Alright, so again, it's really not my experiment, right? So again, let's just illustrate all that crap and just try to clarify this one more time. So we'll get rid of both. We don't need the chat either, I guess. Just get in the way for now. And get rid of that. And do this. Okay. So, the experiment they're evading is this simple idea that in theory, what you can do with a lever. Now, Brozo sort of did it, okay? He did a spring here, okay? And then he did an experiment with a 2 mass here. And then he did the experiment with a 1 mass, twice the distance. Alright, and what he came up with was what you would rationally understand is the same force here. This part of the lever moves that much. This part of the lever moves twice as much, twice the velocity, and you end up with a 1/2 mass with 2 velocity, and here you end up with a 1 mass with 1 velocity. Perfectly consistent with what you would expect momentum to do. The momentum of the spring, the force is conserved. The outcomes are 2 to 1, blah, blah, blah. Alright, so they won't redo that experiment in some form. Instead, they're nailing all this crap, doing all this crap, trying to disprove it in some sideways, bent, crooked way. So it's much like dropping round things into clay. They're just trying to find some way to make the experiment work. Where it won't work in the 99.9% of cases, it'll only work in the one special case. So instead of, okay, pushing things, doing the other stuff, they're now contriving levers that have the mass perfectly centered on the plane of the, so it's not dangling. So as I point out, the dangling thing is sort of important, having the mass above and below, or above and below whatever, is part of why the lever works, okay? And you could make the argument that it works because of the angle changes. So if you have the mass dangling, you can understand when the lever's in different positions. Okay, I guess I could just draw over this. In a different position, the mass, okay, they change position. They are this distance is longer here than this distance here, shorter. And as it rotates, it keeps changing that. So as it rotates, then this one becomes the shorter side, this becomes the longer side, and that's why it oscillates, because it keeps changing the distance, essentially, of the mass on the lever. It's effectively moving the mass across the lever, and that's why it oscillates. I don't know if I will, probably. Yeah, it's kind of irritating. This is still producing way too much glare. I thought I had fixed that, but apparently not. Well, that looks better. Yeah, that's better. I don't know why it didn't stay fixed. Anyway, alright, so now they're rotating it. Okay, so the point I was making is that obviously when you rotate it all the way, it doesn't matter because all the weight is in one direction on the bearing, and so you would obviously say whatever the mass is going to be that mass on the bearing. So obviously in the case of the two masses being close, that's, you know, or a two mass and a one mass further away, it's still just either three masses or four masses, and that the four masses would be heavier, they would create more friction. Okay, so here's this other mindless marbles experiment. So you have the two configurations, but we'll try to just draw them on one mechanism. Alright, so you have the masses in line with the lever. Alright, and so you put the masses in this configuration, and then you're going to give the lever energy. Well, how are they giving the lever energy? Well, the idea is there's a spool here in the middle, so I'll draw that. And it has a diameter. Okay, it's not right on the fulcrum. It's big, you know. Anyway, and they have a cord wrapped around it. All right, and then they hang a weight. All right, so you can sort of understand that. What does that mean to the lever? And that's really just saying that I'm going to be moving a weight. So it's, again, you have to think of it as the weight's moving. So again, when they're dangling, they're changing position, and when you do this, it's also changing position. It's changing the place where you've added the extra weight. So you can understand this is just a weight you're adding, a force pulling down. That's what this is, that's what this is, that's what the weights are. And now you're adding a new weight here, right? So essentially you're just saying, I'm going to add a hunk of weight here on the lever, and it's always here. So as the levers rotates, obviously in one case, okay, it's pulling, on whatever's on this side of the lever. In the other case, it's pulling on what's on this side of the lever, right? It's adding weight to this combination. So it's a combination of a two mass and a one mass. That's why the lever's falling. That's why it's moving down. It's because you're essentially adding another mass to this side. Obviously this side now weighs more because these two aren't balanced. Alright, so if I change this and I put the one mass out here, okay, I should make it smaller so it looks like a one mass. Okay, and I'll make this bigger so it looks like a two mass. Alright, so now you can see that fix the lever. Now you can see that when the two flip sides, as this rotates, so you put more mass over here, you've unbalanced it, so it would perfectly balance if this and this were on the lever, right? This moves twice as much, this moves one unit, this is half as the weight. Perfectly balances. You're now going to add this extra weight. So this extra weight from here is going to be put here at just this location. It's always going to stay in this location. So that's the weirdness, is that the weight is always here. It doesn't rotate with the lever. The weight always just hangs down here like magically. You could just keep hooking the weight on, and unhooking it as soon as it moved. You're just putting the weight, the pressure in just one location. So obviously when the lever switches position, okay, that's the little end now is over here. I guess we get rid of this and get rid of the distraction of that. Alright, so still there's a weight on here. Alright, Okay, so when the position is turned, right, and so now you have the two mass here, and you have the one mass out here, you can see that it's still pulling from this side. So now this side is still got the extra weight on it, all right? And now that's different, right? I mean, I don't have the same configuration. What I have is a two mass, and then I have a one mass on the other side plus, okay, this mass. And probably it comes out to some kind of center of gravity thing where the weights end up actually being, okay? Because you probably have to combine this weight with this weight and calculate some sort of different position. But the point is that they don't balance anymore. So this side is going to clearly be heavier because it was the same weight when this was here and this was here. That was the same weight. But this means you're going to change the weight, and so now you don't have a perfect relationship between this much movement and this much movement. You've broken that relationship, so now it's essentially an imbalanced lever, and that's why it keeps rotating, is because you keep imbalancing it by adding this extra bit of weight. But the fact that whether it would rotate at the same speed, can you understand how distant figuring out this mechanism and why it behaves the way it does, and the simplicity of this mechanism where I just said press on here and show me that you can tell the difference between a two mass here and a one mass here, where I'm simply arguing I can't tell the difference, I can't theoretically understand how there can be a difference. And so unless you want to say overtly that you don't believe in conservation of momentum, there can't be a difference. So unless you explain how the lever knows it has to destroy a substantial portion of the energy, and where the hell it destroys it, I mean, how does it destroy it? I don't think you're making much of a science argument. Alright, so the key is I could put this weight, the bigger I make this, the diameter of this spool, will obviously change how much energy is going in how fast, right? Because you could even understand that if I made the spool as big as the lever, I mean, you'd understand that as you're pulling this string off, I mean, this has to drop a lot faster to get the right speeds here, and that the weight would be, it hit the ground, in 10 times the speed. And obviously the further and further in I put it, the slower it puts the energy in, and the slower the weight falls. But it's a pretty complicated gravitational argument to go into how you're extracting energy from a falling weight, because obviously the longer it's in the gravity, the more total weight is produced, the more friction in the bearing, because the whole thing is taking longer to take place. And to not understand that an experiment that happens in 2 seconds is different than an experiment that happens in 1 second, I mean, come on, that's not hard to figure out, especially one done in gravity. So anyway, all of this stuff, like I said, they build all of this stuff, do all of this stuff, and they just won't do the simple experiment where they just oscillate the lever with the one mass on the outside, the two mass here, and then just explain how does it oscillate, 50 times if there's a different amount of energy on one side than there is the other side. How is it possible they can just oscillate perfectly if there isn't the same amount of energy on both sides of the lever? Alright. I think that's enough of a clarification. So, we must watch the rest of this whatever video from this Ian, whatever. This new video I haven't seen, 56 seconds. So again, I make these videos drawing the lever, explaining its function. They won't touch the subject in a kind of reasonable way. They just do these 56-second bullshit videos. Just it's really not useful. Explain your theory. Explain what a moment of inertia is. Because frankly it doesn't exist. Where did this theory of the inertia come from? In terms of it being anything other than a friction forced function. How did that battery get on the ground? That's interesting. Anyway, video.
Just a closer look at this mechanism.
So a closer look at a mechanism where he has not two equal levers. He hasn't weighed any of this extra stuff he has on the lever, and you know, just breaking all kinds of rules. But whatever. So look at all this trouble to avoid doing the simple experiment I described. Amazing.
Same spring on each.
Yeah, unfortunately, it's not the same lever
extend them to
on
the same
each.
distance and apply the same force.
Yes, fine, but they're not the same lever.
Bit of a job to get it all in.
I mean, you can see kind of obviously a whole hunk of the lever's missing. The extra lever has weight. It's part of the weight, total weight of the lever. You can't have different size levers and say you're doing the experiment the right way, or anything like the way I described. Clearly, you're going to feel more weight if there isn't any counterbalancing weight. Even if I do the how much does this thing weigh, and I push on this side. Well, if I don't have the same hunk of lever on that side, it will weigh more because I don't have a counterbalance. I don't have a counterweight on the other side. But I mean, this is just basically a catapult. So part of his argument, I guess, is that you can't shoot light things with a catapult. Which, you know, yes, you can. Yeah.
Shot.
So obviously they're moving at different speeds because the levers weigh different. They don't weigh the same because there's not the same amount of lever. Fuck.
Did you see that the longer one?
So at least he's acknowledging the longer one with the extra amount of wood
Though it's got a half a
moves slower. Yes, so what a surprise. The one that has more wood to move moves slower. That's a big surprise, huh? No, not really.
mass. Wants to accelerate slower.
Wants to. Yeah, it's a very good scientific term. Oh, shit. So that was absolutely a useless contribution. Thank you for nothing there. Okay. I mean, what's the point? It's nice, yes, you should detail your experiment, so I'm glad you took the 56 seconds to show a little bit more details. But again, what you haven't shown us is how much do the bearings, of the attachments device, so I should point that out when I'm talking about. He's attaching a weight, so clearly it makes no sense if you're going to attach a weight. All right, not to, yeah, that's better. You have to take into account that the bolt weighs the same for both objects, so you're really not making a difference, comparing the two different weights, because the total weight of what you've added to the lever to attach this object, that total weight, okay, isn't twice as much. Now, I can't say he didn't do that. I'm just saying he has no reference to it. So he might just be putting a weight on here and saying this one weighs twice as much as this other one out here weighs. But if you don't account for the weight of the bolt, then you've made a mistake, because the bolt now weighs twice as much further out on the lever. So the bolt that's closer only weighs half as much, even though it's the same bolt, as the one out further, because this whole thing is about changing the weight. Oh, shit. Alright. So enough of that. So we'll go read some of the trash comments, I guess. Call it a video. And we'll see if there's any chat people. Mostly the Europeans kind of time, I guess. We're a little early. Alright, I guess I could put this thing back. Yeah, it doesn't cause too much trouble. Jesus. But I mean, yeah, it's just, We might just get to it. If you're gonna look, the whole conflict here between kinetic energy and momentum is, the argument is at any time you transfer energy between objects that have a different mass, the fact is that kinetic energy and momentum will diverge in their approximation or definition of what took place, whether you conserved energy or didn't conserve energy. So the two become completely incompatible. The fact that the two theories can't be called compatible becomes obvious because they're completely different answers. In one case, the momentum says everything was perfectly conserved, and in the other case, like the bullet in the gun, for example, kinetic energy says, hell no, 2,000 joules went one way and only 2 joules went the other way. And that's the part you have to deal with. You have to make some sort of commitment and say, well, either levers work by conserving momentum or they work by conserving kinetic energy. And you just keep pussyfooting around that statement that needs to be made. Will defend the fact that in all these experiments you can explain how momentum is conserved. And you can't explain how momentum is conserved. All right. And not explaining how momentum is conserved is a big deal because your own physics, basically your own physicists, say you have to conserve the momentum. Professor Lewin will tell you have to explain where the momentum disappeared to. Alright. So, I guess we'll just make sure we have the newest pile of rubbish here. More lies and deception. So he's going back to an older video, but that's fine. Now that Mindless Marbles and Brozo have disproven your claim. So that didn't happen. Let's understand the Brozo video, when he did do the experiment to see how much energy, how much velocity the lever produces, it produced the 2-to-1 relationship. The 2-mass billiard ball moved with half the velocity of the half-mass billiard ball. Fact. Half as massive. So, again, Brozo's own experiment made it pretty clear. You have to explain why that experiment was a piece of shit, and then you have to explain why they don't redo it in some better way. Alright. You changed the topic, so obviously the big lie here is who's changing the topic. I made an assertion about a lever and pressing on it. They're spinning a stick and telling me it's the same experiment. Not the same experiment. Okay. Shift to live videos. Yeah, and I explain why. Okay. It's not a bad thing. Alright. So, yeah, I plan to integrate this into video making, and it doesn't hurt. So I've made the video essentially, right? I've made the counter argument. I'm reading comments just as I would do in a video, and then I'll allow there to be somebody else interacting if they choose. What exactly is a flaw in that process? How does it encumber the argument? That's right, does it? Alright, as usual, hide within absurdly long videos. So obviously the videos have a format. Like I said, if you just want to see the physics argument, you watch the beginning of the video. If you don't want to bother with the chat, you just don't watch the end of the video because it won't have the original subject of the video in it. It might have some other subject. So again, just a lie to stave off criticism. Here I am reading your opportunity to make a counter argument. You could make a physics argument here, but instead you've chose to say absolutely nothing, and everything you did say is a lie and a distortion. So you're just proving my point. You're providing evidence for my case, where I'm going to argue that look how dishonest these people are. You say something, they completely distort what you're arguing. They say you said when you didn't say any such thing. I didn't say anything about spinning shit and all this other crap, much more complicated circumstance. I talked about a simple thing where a 2-mass, half the distance on a lever, weighs the same as a 1-mass, twice the distance on the lever. That's what I said. Prove that isn't true. They're just so dishonest. So you can just see, this is the desperation. Alright. Hi, I just figured out you are part of a community all tarding out on springs. I think it's obvious who's a tard here. But anyway, very cool. You know, that makes you sound a little tardy. Okay. Also, could you unblock me? Why the fuck would I? I gave you your opportunity to be somewhere on the subject. You couldn't manage it. So, what's the point? But, you know, okay. So, and you obviously, look, I've already pointed out, you want to get unblocked, you have to email me a link to your channel. Because YouTube really doesn't provide a good unblock list. You know, it's not alphabetically ordered. Names aren't on it that should be. It's really not very useful. Alright. Let's see. More, but I mean, just what's the chances that there's any point in unblocking you? I mean, I'm not doing a community thing. I'm not tarding out on springs, whatever that fucking crap means. I'm really not a very cool person. So what the fuck? Where do you think we're going to relate? I'm, you know, old. And you're what, 9? Shit. Anyway. Are you the guy that simulated Pong? So, you know, this is some idea that all simulations are useless. And, oh, you did it. I mean, just a pointless, derogatory comment. So let's just, for the sake of argument, you know, so this is their grand debunk of this simulation as being damn impressive. I mean, it's showing you exactly, it's functioning exactly how electrons and protons would behave. That is, repelling each other, same kind, and attracting to the opposites. Creating dipoles, essentially creating little magnets, and doing it with really simple force law. It's just a constant amount of force. It just has two different interactions, really simple rules, and it's creating the fundamental elemental function that takes place inside any atomic theory, the creation of charged elements. That's just something to mock. I mean, that's how fucked these people are in the head. They have so little respect for their science, the process of you know, understanding, the whole idea of modeling, the whole way you get to the truth. They have such contempt for it because it's anti their religion. It will destroy eventually their religion, and this is the big threat. That's what they're afraid of. But I mean, what a just pettily stupid comments. You're just saying this, you know, you think you're winning. Again, I'm just arguing. Anybody who's got any kind of fairness, integrity, would say, gee, that really is a desperately stupid comment to make. You can't do better than that in your counter argument. Alright. Hey, next time you talk to Dr. Castro, so this is like a Farley thing, right? I guess I'll have to see what the IP addresses are on these comments. There's whatever this whole Dr. Castro obsession is, right? A guy posted 3 times on my video, I will debate you, right? And my simple response was, well, get to it. But apparently he wants me to pay him to debate. I'm not going to pay a nobody to debate me. I don't gain anything from that. There's zero benefit, okay? It's of no value. It's fine if you want to do it, but you know, the whole way you debate somebody is you do exactly what I'm doing right here. You play their video and reply to it. What is so complicated? So if he could have managed that feat, then I clearly would have played his video and we'd heard his great counter argument. But after he said, I'll debate you, then he said, what are the subjects? I mean, can you get more pathetic than that? So why are we even talking about him? It's because this is what trolls do. They waste everybody's time with some fake notion that there was some fake person who was going to do some debating of some kind. That never existed. It's just a waste of time. Could you ask him if he used MGT or 1/2 mv squared at CERN? Well, the point is let's ask him if he used it at NASA. Because guess what? I'm pretty damn sure he knows that NASA scientists and space navigators understand that MGT is the one that works. They don't really worry about height anymore when they're in space, you know. Idiot. But whatever. Moralize and okay, here is his thesis. He measures energy at CERN. Right. So he's got him working in two different places, frankly. So he worked at NASA and he worked at CERN. Now this is just his thesis. So he didn't work at CERN. He just took data from CERN. So again, and his thesis is some kind of nutty crap about some sort of jets from some sort of antimatter crap. I mean, it's the kind of crap that who could evaluate it? It's, you know, it's kind of unevaluatable mush. It's so abstract and disconnected from anything real. Alright, it's about energy at CERN. It's not about energy. It's about some bizarre jets and bullshit about what, again, matter in some sort of non-real state does. So you're talking about high energy collisions inside of colliders and some sort of whatever energy. You know, fuck you. It's just so abstract and bizarre. But anyway, what's the point? What are you defending here? I don't even understand your point. What do you think Dr. Castro can add? He can't write a comment. He couldn't produce a video. And yet you think he has some counter argument to make when he doesn't even know what the subjects we're talking about are. I mean, how do you rationally do what you're doing here? So I guess I'm just going to say I'll block your IP. If you keep bringing this crap up, I'll just block your IP because you're clearly just trolling. You might as well just keep saying something like, there's dirt on your shoe. There's dirt on your shoe. I mean, just keep saying something completely moronic. So anyway, alright, so we already did this crap. 420 friendly people. Oh God, they're just so bad. The human race is so broken. So useless. Alright, so we don't have any comments, so I'll give you a couple of minutes if there's anybody here that wishes to say anything. I will just call it a video. 8 current viewers. Ugh. But you take what you can get, right? 8's better than nothing, I suppose. But it's pretty bad. We'll move this over here and make things more colorful anyway. I don't think there's any other comments. I don't think there's any comments in my comment thing, so don't believe there was any new ones. No. Nope. Okay. So nothing to see there. And so we'll go back to this. And, yeah, so see if anybody has anything to say. And if not, we'll call it a video. Such. But really, the only thing at stake here is some definition of what do springs capture. So we know we can capture energy in a spring. Is it capturing momentum or is it capturing kinetic energy? So do you think that if I put a half mass in front of the same spring compression that it will move with twice the velocity? Or do you think it'll only move with 0.4 more velocity? Because that's the only way you can conserve the kinetic energy, is for the half as massive object to only go 0.4 faster instead of a whole unit faster. So it going 0.6 missing, you know. Well, it's not it's 0.6 of 2. So, you know, 1/4 of the energy has to be disappear somewhere. And I would argue you have to have the same argument for levers, that somehow the lever can't convert the momentum. So even though it oscillates perfectly, somehow it can't do the conversion. It can't make the lighter object move twice as fast. Even though it does it clearly and oscillates perfectly while doing it, the argument is it can't leave the lever at twice the velocity. So even though the lever is moving with twice the velocity and the weight's, hanging, I can't make the object leave with twice the velocity. So even though the lever is pushing it at twice the velocity, if I try to force it to leave the lever at that velocity, it won't. So if there's some instant way I could just cut the lever with a laser beam, somehow, even though the object's moving twice the velocity, it'll stop moving twice the velocity. That's what they're saying. Yeah, well, I don't know. I'm happy for you that you're making coffee, but that doesn't do me much good. YouTube's notification process sucks. I didn't get a notice until 45 minutes into the stream. Well, I figured that was happening. So if you look back to the earlier streams, the view numbers were higher, and the participation rate per numbers of people showing up was higher, and so yes, it just seems like they do delay the process. But whatever. We really don't need a conspiracy in the sense that it's also a fact that that's the whole problem with this channel in making these arguments, is there's too few people in the argument. I mean, right now all there are Gary haters and a few curious people, but there's nothing else. There's just not enough expertise in the conversation. Not too many physics graduates. Yeah, well, it's nice that somebody gets something out of it. I think it's like I said, I think it's a reasonably useful enhancement in the sense that some of the questions are good. It's good to figure out where I'm saying something that might be people aren't interpreting the way I think it should be interpreted, so they have a misunderstanding, and I can clarify that. So all that's also good. I'd argue that it is a little bit less efficient than just some directed argument. But I still have the directed argument at the beginning of the video, so I'm just saying that's, it's just a response video plus. It's not like there's something taken away. It's essentially just added value. So for somebody to complain about it is kind of retarded, because if they want it the way it used to be, just only watch the first half of the video. So that's pretty much the old video style, is in the first half, and then if you don't like the chat response crap, don't listen to it. Gee, is that too complicated? No, I don't think so. But it is funny that the Ian Gosling guy is preaching, like he knows, and he has this theory about inertia, and it's a big important word, and it's the squared function, and blah blah blah, and then he doesn't know that if he's going to do a demonstration to show the difference between two circumstances, that he has to have the same size lever in both experiments. I mean, come on, you really can't preach if you're going to miss something that obvious. I mean, if you're going to get that one wrong. So, I'll give you the 2-minute warning again. Say, oh yeah, the pressure's on, Adam. I'm gonna have to say something. I really will type some questions I'll make up. That's what I'll do. I'll make up questions, and then I can post my made-up questions and then answer them. For the, fill in the dead spots. And I'll call it whatever, AI Gary bot or something. AI Gary bot says, you know, it's just it's so crazy. Oh, I should have checked this Bar's channel and see if he has anything new. Now that he's posting crappy videos again. So the interesting thing is Toady does seem interested in doing some experiments, which, well, that would be great. Let's see. Unfortunately, I've never been very deep into physics, but my interest has grown. Yeah, well, to me, it's compelling when people are saying shit that's just completely idiotic, and you just can't help yourself and say, no, you can't believe that. Come on, too stupid. Yeah, well, I was early, so it's you can be late because I was early. But yeah, I mean, I wish I had thought more about physics. The possibility that physicists were idiots, but I really believed it too. I mean, I worked in technology kind of early, in the sense when I was 17, I worked in a machine shop and, was doing kind of innovative stuff in the sense we made control devices for machines. So it was essentially robots. It was like they were sort of disembodied robots. We were making the brain for the robot, you could argue. And but we did have to make the sensing devices. So it was kind of interesting in terms of you really had to get a pretty good understanding of electricity, circuit boards, and the sensing part, I guess, was the really interesting part, because for every machine you're sensing with, in one case with a wire that gets wiggled, in another case we were using the LEDs, which were brand new technology back then, and and reflecting light off a surface, and all of that kind of stuff. And so it really was interesting. But the capacity for me to think outside the box, I did actually come up with a pretty good innovation where I suggested a modification to a machine that they were having trouble coming up with a controller for, because it was doing wide sheets, like 4-foot long sheets, I mean very big rolls of clear plastic, and had to detect holes in the plastic. And they were having a hard time doing that with LEDs and getting a consistent light pattern, and then being able to receive the signal consistently. So it would pick up just every time the sheet moved in some kind of funny way, they'd get a different signal, air flow and all that stuff, and the thing's moving pretty fast, and you have to detect these flaws. Well, anyway, so I ended up suggesting solar panel material, so using the little, and because it was just fast enough, responsive enough, it could pick up just enough photons, and then you could use one light source, like a big fluorescent light source, and so you had very even lighting, and so you got so anyway, it was pretty smart of me, for 17. But yeah, I didn't, I was just saying you learn a lot, because you have to learn how to use this machinery without cutting your hands off, and all that kind of stuff. So it was really a very useful couple of years. Yeah, it's just unfortunate. Again, my anxiety disorder got in the way, and I ended up having to live kind of an isolated life, and blah 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 blah. So who knows how much of this I would have gotten into so much earlier. And so I didn't get back into this, back into really thinking about it. I did lots of whatever, inventing, on my own, but I didn't do any, real research into physics. And I wish I had banged against it a little harder, because I just didn't realize how wacky it really was. The conventional bullshit. Yeah, I'm lucky I didn't have any, whatever that's like, catechism or something. So, yeah, but school obviously wasn't as enlightening as you would have for all the time you had to spend in the, the stupid building. You don't learn much. Yeah, it's like, it's the nerd syndrome, They can know stuff, but you can't rely on them. You wouldn't want them to be throwing you a life preserver if you were drowning in the ocean, because they won't be able to figure out how to throw it, So they can do all their calculations, they can do all their shit, but, they'll fuck up on something really simple. So, it's a very unbalanced intelligence. And that's that's what I'm discovering, is that they're just specialists, and they're of no value as generalists. So that's why all the rudimentary and elemental physics has been destroyed, is because they're just about their specialty. It's sort of like if somebody was to make an airplane in different places, you could understand that maybe the guys who made the engine aren't thinking, oh, the plane has to be light, so they make the engine incredibly heavy. All this kind of different stuff. It's like they're too disconnected from what they're making. They're too obsessed with the particular thing they're doing, and so they make, they make something that's a half submarine and half an airplane, and it's just not going to work. Because they're just not grounded. Let's see, okay, but now I've been learning that assumption is wrong. Okay, seems like there must be a strong correlation between having a deep thinking intellectual mindset and being prone to disabling anxiety. Well, I think any kind of intelligence is going to get you in trouble, right? Most of it. Because, all the the facts suck, right? So the more you know, oh shit, the more you almost wish you didn't know, It's like going to Las Vegas. It's not much fun if you're saying that every time you pull the arm on the bandit, you say, well, there's a 1 in 32,000 chance that I'll make a profit. A 32,000 chance. What, oh, okay, let's not do this. Let's go do something else instead. So if you know what the odds are, you're not going to be, and when you know how life works, that's almost like you can't even breathe without fucking something up. That's depressing. Certainly worrisome. It's certainly worthy of worry. So the more, the more worrying is a good idea. Because there's a lot to be aware of. I've kind of argued that, an intelligent person just can't raise a child, right? Because it's such a problem. What is the right thing to do? In every circumstance. Shall I hug him or shall I smack him in the head? What's going to do him more good? There's just no, yuck. There's no really good playbook. Being forced to practice a religion you don't believe in really stunts my growth as a person. Yeah, well, probably. I mean, it depends on how distracted you are by it, I guess. I mean, I didn't believe, and I actually had to go to youth, thingies, retreats even went on retreats, you know. And you just kind of, you sit through the stupid parts, and then there's some parts where they even, they'll let you make a counter argument. And you make your counter argument, and well, what if Jesus was just a man, and what if blah 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 blah, and can't I just be a nice person? And then they tell you, well, no, the Bible says it doesn't matter whether you're a nice person. Okay, deeds aren't going to matter. You have to be baptized, and then you have to say you're sorry, and if you don't do that, you're doomed. But I'm just saying, it's, I guess you have to try to just say, okay, this is just part of the game you have to play to get through your life. But, eventually you'll be liberated and won't have to go to slavery indoctrination theory courses or whatever. Alright, so a lot of biased assumptions and denial. Well, I just mean that the fact that for a long time now, whatever, 4 or 5 years, I've been saying, why haven't they repeated the Eddington experiment? And that should be pretty glaring to an honest person saying, yes, we should investigate these truths and we should get evidence. I mean, they can't admit that it's pretty lame that when we had a perfect eclipse, 12 noon, I mean, that's really not very common. It's the shortest distance through the atmosphere, so it's really ideal. Eddington's eclipse wasn't ideal. It was 2 o'clock in the afternoon, so it was through a lot thicker atmosphere, besides the fact that it was raining, but anyway, just the humidity alone, gigantic problem. So anyway, so perfect eclipse over this beautiful dry territories, the whole thing. You could just say it couldn't have been better conditions, and over the most technically advanced, just right over North America, split right through it, and no telescope bigger than a 3-foot little 4-inch lensed telescope did the Eddington experiment. I mean, we're saying, what the fuck? How could that possibly make any sense? I mean, even all the amateur 12-inch, telescope. I mean, all the, much better telescopes. And it's a $300 telescope. One amateur does the experiment. I mean, that's kind of amazing, isn't it? Come on. And they can't even just admit 400 times better resolution from space, and you don't need an eclipse, and they still won't do the experiment. You gotta say that's that's contempt. That's an act of contempt of court. I mean, that's just saying we don't want to have evidence in the trial. We want to have a trial without evidence. Alright, whether they have high intelligence or not. Right, so they can know all the capitals of all the countries in the world and all that kind of crap. They can know all kinds of little specific equations, but they're assholes anyway, right? And that's really the definition. They're just, shitheads. Because they don't know how important evidence is. They don't have any understanding that before they say something's the truth, they ought to really prove it. They ought to be right. They ought to make sure they're right. The experts are not willing to be critical and admit problems. Yeah, they are running from any argument. That's why they're wasting all their time beating up flat earthers. It's because they want to create a fake adversary. Okay, I wonder if the reason some of these physicists don't debate has something to do with their fascination with their theories like dark matter. Yeah, they don't, they have no interest in even doing the minimum research you need to do to understand who Leibniz was. But even when they do it, right, the Wolfram guy is actually a Leibniz expert. He did a whole frickin' paper on Leibniz. And what did he do? He didn't mention solitons and monads at all. I mean, that was, the basis of Leibniz's theory of reality, was this idea that matter had a soul, and God didn't have any. He didn't leave any atoms behind. All the atoms were soul enabled. I'm just saying, it was just such an unfair profile, because, and you're just saying, how could he read the actual history? You can't really read the actual letters of Leibniz or the actual stuff without falling all over his religiosity. And he completely, minimized that fundamental aspect of Leibniz's personality. I mean, they really are viewing everything through their little pink glasses. Have you heard of the 1973 ESO eclipse expedition in Africa? 1973. There was one they did. Like I said, every time they did this experiment, they fucked up some way or another. So I think that's the one where they had a really bad eclipse, like 3 o'clock in the afternoon. So it was really late in the afternoon, and really a bad angle. I had never heard of it, but it was just trying to look up follow-ups on the Eddington experiment. Yeah, no, they tried it a couple other times, but like I said, one time again it was a data problem. They did something wrong with the calibration of their telescope, so it was out of focus or some kind of bullshit. And then, like I said, the other experiment, everything went well. It's just they had kind of a shitty eclipse, so their data wasn't very good. I mean, they couldn't get their margin of error, outside of, they couldn't get their results outside the margin of error, because they had so much, atmospheric noise in their images. I mean, that's why the space argument is so compelling to me. I mean, it's 400 times better resolution. I can't, when you hear that number, and you just say, oh, no wonder why the Hubble gets so much better images with such an inferior, lensing system than what you could have on Earth. And, it's that 400 times better resolution. It's really a gigantic advantage. I mean, I would think it would be totally insane to build another telescope on Earth when you think about it, because it's just like, oh shit, you got to be able to take advantage of that 400 times shit. Certainly for optical light, you just can't, it's just undeniably huge advantage to getting the thing up in the air. I mean, up out of the air. Yeah, well, whatever. This dark matter stuff, again, there's so many reasons not to believe it, but just understand, the dark matter is to fix the broken mathematics. So what you're trying to do is basically find an excuse why the gravity is incredibly uneven. And you would say, well, why would I want to say that anyway? Even if there were planets, why would I think they would be in a place that's gravitationally impossible? And essentially that's what you're saying. The dark matter has to exist in places that don't make any gravitational sense. They're basically creating a gravitational object, okay, that isn't affected by gravity, but produces gravity. So therefore you can put it in ludicrous positions that don't make any sense, because it doesn't have to obey gravity, but somehow it makes gravity, if you get my point. So it's, and again, it only exists because they need to fix their math, just like the neutrino only exists because their math doesn't work. So they had to create some other object that was an energy carrier. I mean, 1/2 mv squared has created a lot of phantom matter. I mean, that's the funny part. And it's totally understandable in accelerator physics, right? Because the whole idea of accelerator physics is to maximize the speed of objects. And what are you doing with the squared function is you're increasing exponentially the energy of any energy you put in. You put energy in big protons and electrons, and then you're surprised that you have this tremendous amount of energy out, because statistically, yeah, that's what your formula says has to happen. As soon as I convert the big things and bang them into little things, I'm going to end up creating a bunch of free new energy. And that's why they have to create all these extra bits of shit, is because they have stuff that's happening that they can't account for, because their formula says there's way more energy than they see particles. So they have to, that they see in the particles they know of coming out. So they have to invent phantom carriers. Yeah, well, it's all quite circular, as I'm just now pointing out in the last couple of months. I mean, I'm tying now 1/2 mv squared to all the crap they use to circularly justify it. So the work equation, again, conventional physics says I'm doing no work by holding this in space against gravity. So we know I am doing work. I'm pushing it up against the gravity. I'm holding it against a force. There's no doubt that I'm doing work. But their physics says no work, because I didn't move anything a distance that we can see. So therefore there's no work. I mean, it's that bad, right? And obviously the argument would be is that if I calculated the force, and I calculate how long I held the force, I've held this against the force, that would be the rational calculation of how much work I did. It's about how long did I oppose the force. So, I mean, obviously the work equation should be, energy, force, work equals force times time. And the same is true for the gravitational potential energy formula, mgh. No, it's not about how far it falls, because we know it's only 4 times the height, twice the velocity. So it's mgt. It only takes twice the time to fall. Yeah. I'm only in the gravity twice as long. Why should I think why should I think the height is significant when clearly it's the time that's significant? So again, all the formulas are circular. They all are contrived to defend the sacred Holy Ghost. They're just creating a fake story. They create a fake Holy Ghost, and they create some kind of fake narrative to support it, which apparently Christianity doesn't do. They don't even bother, right? The Holy Ghost just happens to be there. There's no backstory. Who the hell is the Holy Ghost? Well, who knows? Dinner guest. I don't know. Yep, it's just a religion. Sounds really convenient when they can... Yes, okay, we did that. They're inventing these ultra-dense, tiny galaxies now to make up for the observations by James Webb Telescope. Yeah, well, I'm just saying they're just grasping at explanations, and they're really not applying any kind of rational scrutiny to what they come up with. So there's not much to say. Look what they did to the Big Bang Theory, right? I mean, when I was a kid, the Big Bang Theory was bang, right? It banged. And now they've turned it into, it went poof, and then it went, and expanded 1,000,000 times in a millionth of a second, and then it started expanding slow again. I mean, how does it know how to do all that crap? That doesn't make any sense. I mean, the whole thing got stupid. And again, it's just because their math wasn't working, so they had to change the narrative. Sorry if I already asked this guy. I have a bad memory, but have you considered writing a paper on Vixixtia? I'm just saying there's absolutely no evidence that they will indulge in the argument, okay? All they'll do is say, well, F equals ma. Here's my derivative. You cannot force them to prove their theory, and they're going to obligate me to disprove theirs, right? So I have to prove there's no Jesus, if you get it, right? That's the obligation. I'm not obligated to just do what they do, not prove my theory. No, I'm obligated to do more than that. I can't just show them a lever and say, look, kind of obvious, right? No, I have to disprove the existence of their gods. And obviously that can't be done, so it's, there's no point. I don't think. They won't indulge in the conversation. It's just they won't. I mean, you can see that on the forums, right? I mean, you post it on the forums. Where's the physical evidence for 1/2 mv squared? And they'll never provide any physical evidence. They'll just say, you're not allowed to ask that question. What are you, an idiot? Of course it's proven 1,000,000 times. Just get the thing where the quantum mechanic guys always say, it was even in that Castro paper I mentioned earlier. It was right in the Castro paper. The Castro guy says, the quantum theory is the most proven theory in the history of mankind. And I was like, and what they're talking about, proven to 17 decimal places. They're talking about measuring the weight of an electron, right? And yes, as they do the experiment more and more precisely, they get this more and more precise number. But it's not even actually the weight of an electron. It's just a measurement of an experimental outcome. And it doesn't prove quantum mechanics. The fact that you can measure a piece of energy in an experiment to 7 digits, how the fuck does that prove the standard model? I mean, it's an insane pile of mush. I mean, to say it's, somehow it's this overwhelming proof and you just can't possibly deny the reliability of the standard model. Of course you can. What the hell? Where's this piece of stunning evidence? It doesn't exist. It's just, it's frankly silly. It's such a preposterous overstatement. But I mean, I never even heard of Vixtra. I mean, how many people read Vixtra? What I need is an audience. I need to have the ideas. I need to provoke somebody capable of making a counter argument to make a counter argument, and that's the hard part. Because you can't pay them to do it, as I have proven. I mean, the Minute Physics guy was interacting, in email, but he stopped answering my points when I asked him, when I pointed out to him explicitly that I'm offering you the money, because he said to me, well, where's your evidence? And I said to him, I'm offering you the $3,000 for you to show me your evidence. That's what I'm paying you for, is to show me. I mean, I guess I could write a paper on Vixtra. I could just say, is there any physical evidence that it takes 4 times the fuel to go twice as fast? I mean, can anyone provide a piece of experimental evidence? I mean, you've been saying it for 350 years. I mean, do you have one piece of videotape of the, 4 times the fuel to go twice as fast? Can you show me? I mean, in a sense, that should be enough of a paper, right? I mean, it should be a legitimate paper for somebody to ask, is there any evidence for this theory? Well, Yeah, well, lenient isn't necessarily good, right? So, frankly, I mean, and you just see what gets published. Like I said, the Castro paper is incomprehensibly complex. So there's no way to read it as somebody with general knowledge of physics. You can't read it and understand the goddamn thing he's talking about. So who the fuck is doing the editing? And what good is the paper if no one can understand it? Well, okay, that's your opinion. I'm just saying I haven't seen this huge interest-generating publication. So I'll look into it, but I'm betting, okay, that there isn't that kind of viewership where you're going to get thousands of downloads and all this stuff now. Hundreds of thousands. I don't think so. I think there's going to be less people reading what I write there than are watching this video. So it's going to be 12. That's going to be the number, 12. And I get 12 an hour, you could argue, right? And I bet I won't get 12 in a month there. So anyway, good enough. I'll be leaving soon too. But like, for example, I am convinced of a lot of your points, but I don't follow the entire thing from the beginning to the end. Yes, well, it's, thousands of videos now, unfortunately. But frankly, I have redone the same subjects, in the new modern videos, and obviously the dominant subject lately has mostly been just kinetic energy and the double slit stuff. But I have opined on the other subjects. Yeah, and I'll continue to do that. So, I mean, it's not that much stuff to go through, in a sense that if you go to the debate page, it has it more organized. And I'll try to do even more of that. You think it's possible that the universe, these kind of questions are going to irritate me. The universe has been in a steady state for a long time without the Big Bang ever happening. I don't think it would be a steady state. So yes, I think the universe is really old. And I think it's been doing a lot of the same stuff, but it's not a steady state. It's, an oscillating state of energy condensation and then energy expansion. The energy gets trapped in the galaxies, then the galaxies excrete the energy to the universe, and that creates more pressure, and it compresses the galaxy again, and then the galaxy expands again, blah, 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 blah. A friend of mine has a paper on there with over 1,000 downloads. I have one with over 400. Well, you should reference this stuff, I guess, so I could actually see what kind of content gets downloaded. But whatever, fine, I'll go look at it. But frankly, I just have my doubts that those are real numbers. But okay. I can't even... Do people have to download it to read it? I mean, I don't even know what this means, that thousands of downloads. Kind of a bizarre thing. And I guess obviously this Vixtra would have a huge incentive in exaggerating those numbers. But whatever, we'll see. I mean, it's hard for me to believe that a place I've never even heard of has all this great science conversation going on. But whatever, we'll see. I mean, you would think some other science video I have bumped into on YouTube would have mentioned this great place where they're publishing all this innovative and great science. Okay, well, I'm not saying you're pestering me, but I just mean you're making an assertion that this is a relevant community of people who are finding this an interesting site full of insightful stuff or something. I'm just saying, if I've never heard of it, I just find that a little hard to believe. But okay, we'll see. I mean, some guy on one of those D. Hilster videos mentioned some place where he publishes, and I went there, and yeah, the stuff he published 7 years ago has 32 views or something, and you're just like, wow, yeah, that really isn't gonna. That's not very helpful. But it is just getting to the right people, right? I mean, you just need the right person. I only need is like 2, even just 1. You know what I mean? Somebody who understands the subject matter, went to the school and all that crap, understands some of these dynamics and can actually explain how a lever works. That's not asking too much, right? In some sort of mechanical way. I mean, it would just be interesting to see a physicist and see him explain how, friction is a counter force or something. And to me, it's clearly just a leak. It's just a place you lose your energy. It's not a place that is counter forcing you. It's not some opposite reaction. It's just the action of you losing your energy. I mean, you're literally just knocking pins down, little tiny ones, but that's what you're doing. That's what friction is. It's just knocking pins down. Yes, your bowling ball loses energy as it knocks pins down because it gave them its energy. I mean, it's hard for me to believe that a physicist could believe anything else. How could they understand the transfer of energy any other way? Alright, let's see. Steady state is an expansion model. Well, does that make any sense to you? I'm just saying, it's not really a steady state if you're saying, okay, well, the universe stays the same, but the space expands. And a lot of extra space is created. But it's a steady state, except for the expansion. Okay. I mean, isn't that just a, convoluted pile of crap? Anyway, they gave up on it and changed it to quasi-steady state now with multiple mini bangs. Yeah, well, whatever. You can't even get a consistent definition of the process, or a conceptualization of the universe. I mean, they draw that funny picture, where they have the picture that starts small and then it goes out and then it does this big thing and then it's funneling out and getting a little bit bigger, like a funnel or something, some kind of weird ass shape they create. And you're saying, what does that have to do with an explosion? I mean, isn't an explosion where it explodes and it just goes out spherically? I mean, what the fuck are you talking about? That doesn't look like that. I mean, it's just kind of funny that it doesn't look anything like a bang, They're just taking all the bang out of the Big Bang. Yeah, I saw that you sent me, and I told you before, I get to things when I get to them, but okay, fine. Some of that's good enough for the background of these videos, certainly little images of space and such. Yeah, I haven't looked at them all yet, because they're in different formats, I think. JPEG and then JPEG, whatever that is, they use the 4 letters. Linux doesn't like the 4-letter files. But anyway, I've got some art too. I wouldn't mind sending it your way. Yes, that would be fine. Art is good. yeah. Sometimes it's very good. But it's always good. It's always thought fodder. Anyway, yeah, that famous image, the Dark Ages part at the beginning, that was, you're seeing how definitely isn't there. What? The Dark Ages part at the beginning, yeah, well, whatever, yeah, that we are seeing now definitely isn't there. Yeah, I mean, well, to me, the whole thing doesn't make any sense, right? Because I'm just saying the light has to be moving the speed of light, right? So you're not going to get any of the light is gone. I mean, it's gone, right? It's the first stuff that left. It's way ahead. It isn't coming back. How the fuck could I see any of that shit? So, I mean, it just doesn't make any sense on its face that somehow we're lagging around and the light from the Big Bang is somehow still shining. How the hell's it doing that? It left. So it's just intuitively not a very good description of banging. But just the whole idea that they would accept a theory where they just say something is, I say kind of silly as, let's go with the explanation where, yes, stuff doesn't poof into existence, space poofs into existence. Just space is just poofing all the time. It's just little new pieces of space, and they push all the other space out of the way. It's just so fucking... Oh, God, no, you didn't just do that, did you? It's like inventing, I don't know, it's like inventing homunculuses that build gods. Oh yeah, well, God, wasn't just but he was built by the pseudo gods. It just he's like the Emperor's Darth Vader. God is. The real God invented the Darth Vader God. Yeah, pretty convenient of them that the light of the cosmic microwave background has not cooled down enough to no longer be visible. But even the idea of it cooling down, I'm just saying, no matter what, it wouldn't be a matter of cooling down. You're just saying, how could it still be visible? It's the first thing that left, and it's going the wrong way. How could I ever see it if I'm on a slow bit? How could I see it? It already left. It's gone. It's like, how can I see it? The light's pointed in the wrong direction. It's going the wrong way. I can't see it if it's not heading towards me. How does the background radiation come back to me? That's the part I don't get. And the only way you can do that is just say it's reflecting off the matter. And then you have to explain, well, if it's reflecting off the matter, then it's reflecting in all kinds of different ways, right? It's all kinds of different distances. So it shouldn't be just microwaves. It should be in all kinds of frequencies. So we should have a whole bunch of cosmic background visible light. Well, anyway, it's just such a convoluted pile of mush. And then if you're going to say there's enough reflected energy, like most of the background radiation disappeared, but there's enough reflected off the matter bits that trapped it before it could get away, then you're almost making my gravity argument. Then you could almost argue that, well, if there's that much cosmic background radiation, why couldn't gravity be the same thing? Alright, anyway. Modern science is biased on the principle. We gave us one free miracle and we will explain the rest. Yeah. Well, I mean, and obviously they're taking that one free one and just taking another free card and another free card. I mean, wherever they can. Again, Einstein's bent space, isn't that just a desperately vacuous explanation? I will invent the invisible magical entity that creates gravity. I mean, you can't account for it, you can't test it, you can't do anything. It's a completely it doesn't do anything. It's not a source of energy, right? And they're conveniently just taking advantage of the fact that yes, it takes as much, whatever energy you get from gravity, you have to, it all gets taken back trying to escape the gravity, so they can make it energy neutral. But do you really think it's not energy? It's just so amazing that they come up with this non-energy solution when it's clearly energy. Let's see. Oh, wow. I see what you are saying about the background radiation. It's all moving away from us. Yeah, well, it should be, right? Theoretically. You're just saying we're made out of the atoms that didn't go the speed of light, and that stuff was going the speed of light, so why should it be anywhere near where we are? Well, the expansion is so slow, that's why we can't do the experiment, because it would take 1,000 years to do the experiment, I guess. And I don't even know how they could, it's such a tiny little expansion that you're trying to measure. How could you know that your instruments didn't fuck it up? And, because you'd have to measure two things, distances, and they'd have to come up with some reason why they separated in distance. But yeah, it's just so fucking silly. I mean, they're only taking advantage of the fact that they can use this stupid thing because of the insanely huge distances the light's traveling. So they can come up with this wacky bullshit that I can inject an inch of extra space here and an inch extra here and an inch extra here. Enough to fuck up the frequency of the light, but it's happening over insane amounts of time. So it's not the kind of thing they can do an experiment and test for, because there's so little of it happening in real time. I think the claim is that space is not expanding where we are. Well, again, that's the other part that you're just saying, oh, it's conditional. The space doesn't expand inside my body, where there's plenty of empty space, right, between the atoms and inside the atoms. None of that space expands, only the space out there expands. I mean, that's another, well, why would that be? How does the universe know the difference? I mean, it's just so bad. And you can't really go out in between galaxies and measure it. Well, like I said, you can't measure it just because it happens over too long a period of time. So we could measure it, but we have to do like 1,000-year experiment, and nobody's going to do the 1,000-year experiment. But yeah, it's so obviously contrived. It's a contrived solution, and there are no rules to the contrivance except make it completely unverifiable. So as long as you come up with an explanation that's completely unverifiable, it's legitimate. I mean, deniable. That's right, deniability, falsifiability. Yeah, that's the word they use. It's completely unfalsifiable. I mean, I can't prove there's no bent space, but I can certainly explain how there's got to be a better explanation, because that's just too fucking silly. I mean, how do you prove there's no invisible man? It's like, oh, okay. I mean, I can prove it because it has every stench of being a made-up story, in the fact that, well, there should be some evidence, who made the invisible man, or there should be some collective evidence of his existence. But yeah, it's really hard to prove there aren't invisible people. Beyond saying it quacks like a three-pig story, Well, if it quacks like a three-pig story, and it waddles like a three-pig story, and it has feathers like a three-pig story, yeah, it's a three-pig story. A Santa Claus. It really is, and it's almost embarrassing when you think about it, because they really are supporting things that really are as silly as Santa Claus. I mean, they're so unscientific. And so desperately unfalsifiable. So, alright, well, heading towards the end, I think. An hour and 40. Let's see, I gotta do some stuff. Well, I have a few more minutes, so we'll see if anything happens. Like I said, I should make my own comments to react to, so when we run out of comments. What's yeah, let me think, how can I think of a question? I should, like, something like, well, do you think Newton predicted anything that's completely dependent on only momentum being valid, where 1/2 mv squared wouldn't work? And I have to say, yeah, that's tricky. Because it is just a bunch of, observation data. And so you really can't argue about how fast something was going or how it's moving. And so kinetic energy really doesn't come into the argument, because you already have an explicit definition of a velocity. So I don't know if there is a I guess his bucket experiment was good. I mean, I didn't even realize how much shit he actually got into, but this whole idea of spinning the bucket and the fact that the water would rise, and he was trying to disprove the idea that there was no absolute three-dimensional space by pointing out that it seems pretty absolute, because you can. It's almost like, I almost think he might have. It's like I've made the argument that you can tell like when two trains go by each other, you could tell which train was moving merely by hanging different weights on the two trains outside and having the weights hit each other. Because if the one with the 10-pound weight is moving, the collision will be very different than if the train with the 5-pound weight is moving. The two things won't hit each other the same way. And so, one of them has to be absolutely different than the other. They can't be perfectly, relatively independent. There has to be some aspect of them that is fundamentally different for the collision to be different. Little proofs like that are, but there's so much, there's just so much material to go through. And Newton's really hard to read. I mean, he wrote it all in Latin, and then they translate it, and it's, I don't know. It's difficult. Yes, I'll go ask the chat bot. Oh, yeah, my best friend. It's just funny. It's just. It's in a way, I guess the chatbot thing is like my worst nightmare. It's like making the Wikipedia robot. It's just like, oh, what a bad idea. Let's see. Do you have any thoughts on? Dirac was a lunatic. Okay, so that's my. As soon as I hear the word Dirac, I just say, why did anyone pay attention to this kook? But anyway, large number hypothesis. It doesn't mean anything. I mean, obviously, yeah. I mean, the idea is that in systems with an insane number of permutations, almost any kind of crazy crap can happen. So what? Yes, we all agree with that. But I don't know if there's any kind of hypothesis that goes with that statement that means anything. He suggests big G constant changes over time. I know, but he doesn't suggest it for any good reason. I'm just saying he's the one who created all this antimatter and all this other crap. I mean, obviously his understanding of what's in the universe was really fucked up. And I think you suggest this as well. Yes, but I suggest it for a really rational reason, that there's not a different amount of energy in the universe, that the fact is the energy is in different places. So it's like there's two places it can be, inside the bubbles and outside the bubbles. So if you think of galaxies as being little bubbles, like little water bubbles, and all you're really saying is I put pressure into the water bubble, I compress it with force on the outside, and that makes more force on the inside. That means I'm creating more motion that's using up energy. I'm pushing more matter around. The matter's occupied moving more when it's compressed. Higher pressure, more heat. So I've made more heat on the inside. It means the outside had to get colder. And so now there's less pressure on the outside and the bubble gets bigger. So I'm arguing it for a perfectly rational reason, where I don't think Dirac did any of that, because Dirac just cared about numbers. He just cared about math. He didn't have any concept to tie to any of the mathematics. Wikipedia robot, but with even more biases and disinformation due to the language model hallucinating and coming up with imaginary stuff. Well, the fact that it doesn't really understand the distinctions, like birds and planes both fly, but it really doesn't understand that birds evolved and planes were built by humans, and it can't do all of that subtle understanding. So it's going to make grotesque mistakes. But this is all really based on Grammarly. You know what I'm saying, in the sense that the really great feature of the bot is that it knows how to construct sentences, because it knows probabilities of what words follow words. And so it's really good at constructing nice literate sentences. So it can say completely nonsense, contrived, just let them hear what they want to hear crap, and it can say it very charmingly. And so that's the real, that's almost the thing I want to take advantage of, is that yes, I'll let it write my paragraphs for me. I put the 3 sentences in and then it forms the paragraph. I might use it for that purposes, because that's where I fail, to have much talent, is in grammar. I can write very run-on sentences. Wikipedia robot. Okay. Let's see. Or whatever loose associations, conjectures you could call them, inside a language model neural network. So the words neural network, language model might be one thing, but neural network. So what does language model mean? So language model again means associating words with words. So, you have the word fire. Well, the chatbot knows that the word fire is usually preceded by this word and usually comes after it this word. So it has a list of the probabilities for what comes before the word fire and what comes after the word fire. And that's its language model, okay? That's the extent of the language model. So you have to kind of understand what those things mean. And neural network is just a way of basically saying, that neurons kind of work on this idea that, one unit has 12 subunits, and then, you just multiply that out, it becomes an insane number of interconnections. But each neuron is really only connecting from A to B. It could have connected to 14 other things, but it really just connected to A to B. Let's see. Yeah, I work in NLP. Oh, neural network. No, neural. Well, loser planning. Neural. Yeah, well, something, right? Something neural, no doubt, right? I don't know what it is. Sorry. I'm really bad at. My bot is really bad at the anagrammy thing here, whatever you call those things. Natural language processing. Okay, thank you. Yeah. You're just, it is kind of funny, even the word, putting natural in front of language, right? You could say, well, how often is natural in front of the word language? It's kind of an interesting, what would be an unnatural language, It's kind of funny. Just the whole way language is used is so funny, because you can tell how desperately bad somebody's argument's going to be by how many multi-symbolic words they put in what they wrote, right? Or what they're saying. And so there's so much jargon in philosophy, you know. The ontology. Why would I use this word? What the fuck is an ontology? What the hell is that? You know, how many, you could just, how many children's books have the word ontology in it? You know, it's just such a funny concept. A is for apple, O is for ontology. Right? Or ontology, right? I could probably start it with all kinds of different letters and get away with it. Ontology. Yeah, and the joke is that is used to mean neuro-linguistic programming back in the day. Yeah, so it's funny. Yeah. They changed with the, what is that? That's a, shit. 60-year-old brain. Come on. Yeah, so, damn it. Fancy words are like a fancy facade. No, they're more, I think they're more like, yes, it's a facade, but it's a facade with like, the big clown face, with the opening where the mouth is or something. They're traps, they're word traps. They're places that are trying to seduce you into thinking, you're going to see something profound when you're not. They're such aggrandizing. It's such gold plating, that kind of thing. So it's like plastic gold paint. It's, the words are being used to aggrandize and embiggen, and just to create more deception. To make deception more possible. It's just to facilitate the deception. I guess that's what I would say. It's a kind of weird sugarcoating, because the fact that it's completely useless on the people that need to read what you're saying is the ironic funny part, right? The people who need to understand the argument are the people you've lost by using the obtuse language. Alrighty then, I think it is time I have to go do my real life work. So last comment. Yeah, that's what I'm worried as well, now that powerful language models are out there and basically you can use them any kind of PR spin doctor crap. Well, it's the fake news thing, right? It's all quite scary that people get away with really overtly lying, creating completely fake associations, and the internet makes this association. It really does connect people to things for which they don't deserve to be connected, and it's a real dangerous weapon. It's been used against me. In the sense that there was one of those school shooters actually watched one of my videos, right? He watched other people's videos too, but he actually watched one of my videos, and somehow I'm now liable for this. Somehow this completely tangential connection, in the sense that he actually described me as being too much of a moralist. He didn't like me, right? So that's the irony, is that he found me repugnant in my values, because I had some. And, but yeah, that's a real connection, and so people will make, that all these little artificial things will become your 7 degrees of connectedness, are going to be 7 degrees of connectedness to absolute shit that doesn't really have anything to do with you. And that's the danger of these popularity engines, and the very idea that very few sources are controlling the mass of data, because all of these pages are trying to copy the one page that gets the most views. So the most viewed page on the internet everybody makes a copy of it, distorting it a little bit so they can be connected to it, so they can get views from it. And then that looks like confirmation. So it's like people watching a video because it has 1 million views. So they click on it. It's a piece of shit, but because it has 1 million views, everybody clicks on it because it has 1 million views. And, you know, it's completely fake. And it's like, this isn't what we should have driving what goes into the library, right? I mean, what's in the library or what's accessible. Like, you don't have to climb a mountain to get to the good books. You want the good books easy to get, and you want the shitty books on top of the mountain. And it's exactly the inverse. You know, the common trash is really accessible, and the valuable stuff is getting more and more obscure as they keep piling up all the fake confirmation data. All the fake narratives only created to generate views. It's really, yes, it's a horrible feedback loop. And, you know, Google is showing it. I mean, Google is becoming profoundly useless as a search engine. You know, I find myself actually going to the original, you know, going to source pages and searching because there's no point in doing it on Google. Alright, but anyway, do have to go. So, thank you for the interaction. It was pleasant enough and seemed to work adequately, and so that's all a good sign. And such. So, till the next time, I guess I'll hit this end the stream button this time, see if it's any different. Maybe it'll cut off everything I'm saying now. You know, who knows? We'll see. I'll hit it.